hard to look right at you, baby, but here's my number, so call me maybe.
Hey guys, so I'm going on a trip for winter break with my parents to Aruba. I'm super excited for it. But my mom just told me that she's only paying $150 for my bill, which is ridiculous because everyone knows that there's roaming charges when you're abroad. I have to call AT&T and see what I can do about this situation. Hello, AT&T?
AT&T, this is Catherine speaking. How may I help you, fellow customer? I understand your concern. It is very difficult to go out of the country with a regular phone plan. If you would like, you can pay an extra $5 for World Connect, and it'll only be 1 cent per minute when you go abroad. It's a lot cheaper than it will be with your current plan. I can walk you through a linear equation which will help you decide how many minutes you can use abroad when you pay for the World Connect.
There are two different approaches to solving this problem. We can either use written equations, as we covered yesterday, or use a graph, which we have learned today. First, let's solve this problem with a written equation. The equation for a linear problem is y equals mx plus b. Within this equation, the y value will equal the cost of the phone bill. The x value will equal the amount of minutes that we are able to use while in Aruba. The m, which we have learned yesterday, represents the slope of the problem. It is important for linear equations to have a constant slope or rate of change, and in this case it does. It is 1 cent. The b represents the y-intercept, or the beginning value. We remember this as the value in which x is 0. So when there is no minutes being used, how much the bill costs. The student had mentioned that she was using a $40 phone plan, but she would also be paying an extra $5 for the World plan. So we will add these two values together to get 45, which will be our y-intercept. The problem written out will look as follows. Y equals 1x plus 45. The student had told us that she is only able to spend $150 on her phone bill. So that would be the y value. So we set 150 equal to the equation. And now we must solve for x, the amount of minutes that we are eligible to use. So now we will minus 45 from both sides. And then divide both sides by 1. And x equals 105 minutes. So this student is allowed to use 105 minutes while she is over in Aruba. We will now use graphs to solve the problem. First, we must start by drawing an x and y axis and labeling them. This is our x-axis, which is also the minutes. And this is our y-axis, which represents the cost of the bill. As you can see, I did not center my graph because both the minutes and the phone bill will be positive. So we're going to be focusing on what we call the first quadrant, which is this area right here, because our phone bill will not be negative and neither will be the minutes that we use. So now, as we know, a linear line is represented by y equals mx plus b. We have previously found that our linear equation is y equals 1x plus 45. Now, we must label the increments that we will be increasing our axis by. I'm going to use tens for every line, and I'm going to label every other one. I'm going to stop there, and I'm going to use the same increments on my y-axis as well. Now that we have that completed, we will look at our equation and begin graphing our equation. So first, we must look at our y-intercept. Our y-intercept, as previously mentioned, it is represented by b, and we can think of beginning point. So our beginning point, or y-intercept, is when our x value is equal to 0. So it will be placed on the y-axis, because that is where all our x values are 0. And it's the beginning point that we start to create our graph on. So we know it is 45, so I will go up to 45, halfway between 40 and 50, and make a dot. Now that we have our beginning point, we must look at our slope. Our slope is represented by the m, which we can remember by thinking of a mountain slope. And our slope is the rate of change in which our line will progress. So our slope is 1. it is easier to show our slope as a ratio. So if we have a number to create a ratio, we can always just add a 1 in the denominator, because anything divided by 1 is itself. And the reason it is easier to display our slope in a ratio form, because then we can think of it as the change in y over the change in x. Now, our slope is 1 over 1. From here, we use our slope and we go up 1 box and over 1 box and make a dot. Up 1 on the y-axis and over 1 on the x-axis. Up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And if you have noticed, I'm putting them in between because our y-intercept was not directly on a line. After creating a few of the dots, we will use a straight edge or a ruler to create our graph. We must label our graph, which is always important. Alright, now that we have our graph completed, our parent, the mother in this situation, had set our limit for the cost of the bill to 140 or 150. So we will come up the x-axis to 150, or the y-axis, and look at where our equation goes on the x-axis. So we will go down from here. And we can see that it is between 100 and 110. So we will be able to use 105 minutes while we are abroad. Thank you, Catherine. I really appreciated you walking me through the steps of figuring out the whole phone crisis I had. I'm so excited to go to Aruba. I need to go tell my mom immediately about all the calculations that you helped me get through. Have a nice day. I'm glad that I used my math skills to help solve my phone expense issues. I have to go tell my mom I used linear equations to solve my problem. But off to Aruba I go. Guess I'll see her on the way.
You wanna call me, call me, call me. You don't have to worry about it, baby. You can wake me up in the dead of the night. Wreck my plans, baby, that's alright. This is a drop everything kind of thing. Swing on by.